Ben, I'm talking to my class. Hi, all. How you doing? Bethany, you just look thrilled.
Doing good this morning.
Great, great. Larry, you never sent me that a notebook. Hold on a second. Ben, I'm talking to my class. Sorry, my grandson was answering. Uh, Larry, you never sent me that notebook.
I figured I looked at the past email and I see it wasn't attached. So if you don't want to accept it, that's fine.
Attach it. Don't worry about it. All right, ladies and gentlemen, how are we doing today? We're doing something totally different today. This is probably the only time you're going to have this experience doing absorptions. It's really the only time it gets talked about in Chem 1 or 2, okay? So it's kind of an interesting thing. So let's get in it. And it's not really that hard. It involves a graph though. Okay, so I need to share screen and pull up Beer's Law. Everybody see the slideshow?
Yes.
Gaith, what are you doing here? You haven't been here in a while.
Yeah, I've been having some work issues.
It's not like I haven't noticed. Hi, Natalie. How you doing this morning, Natalie?
I'm good. How are you?
Peachy Keen, wonderful. Just happy to be here. I went through a Hitchcock marathon this weekend. Got to see Rope. Let's see, Rope, The Trouble with Harry. What else did I get to see? Oh, Rear Window, my favorite of all time.
Nice.
I'm sorry? Grace Kelly is
I said, oh, nice.
Murder. Yeah, Grace Kelly is the most beautiful woman of all time. Oh, what can I tell you? But this is beautiful too, isn't it, guys? Isn't chemistry beautiful? Your eyes don't lie, guys. All right, we're going to be dealing with something called Beer's Law. Beer's Law is the absorption of light that something has to do with its molar absorptivity, the path it goes through, and the concentration it goes through. You multiply those three things together, you will get the absorbance. Now, if I was looking at these two shirts, they're different colors, right? Now, I'm not talking male. Male colors are blue, right? I was this way too before I started working in Macy's. This is blue, right? It's not sky blue. It's not royal blue. It is blue. Now, there are nuances in colors. And what happens is the type of dye will change the amount of light that gets absorbed. So the dye that's in the royal blue shirt is different from the dye that's in the sky blue shirt. And believe it or not, the sky blue is absorbing more because it's reflecting a lighter color. Royal blue is actually reflecting more of the darker color. Path length also happens, and it makes sense if you really want to think about it. If I double the path length, isn't the light going to see twice as many molecules? Does that make sense, guys? Gaith, you with me, Gaith?
Yes, sir.
Does that make sense to you, Gaith?
We're going to go ahead and say, sure, yes.
It's something, wait. Okay, Gaith.
Yes.
You're at a concert.
Okay.
And you have to get to the front stage. Is it harder for you to get through the front stage if it's some rockin' band that's got everybody packed before you? Or is it going to be just like some local band? Is it going to be easier to get to the front stage?
It's going to be harder to get to the front stage.
So Think of these guys as being in the front stage. The light has to get through them. It has to get through more of them than it does over here. Same thing's going to happen if I double the concentration. I'm still going to see twice as many molecules, right, guys? So either way, whether I do the path length or the concentration, I'm seeing more molecules if it's more concentrated or if my path length is longer. The thing is, though, we have control over one of those things. We can control the path length. If we keep all of the path lengths at 1 centimeter, it goes away from the expression. So that I can simplify this to be equal to, the absorbance is equal to that funny looking E, the molar absorptivity, times the concentration. If the y-intercept is 0, and this makes sense because if you're at the X line being nothing in there, you're not going to get any absorbance. So it's at the 0, 0 line, at the 0, 0 point in the graph. If that y-intercept is 0, then our expression becomes y is equal to mx plus b. If I plot my absorbance versus my concentration, I'm going to discover what my molar absorptivity is because it's just going to be the slope. Got all you with me so far? Everybody's out there, right? So, yeah, I don't need to go through those. So I'm going to make a graph. I'm going to take my absorbances and I'm going to plot them versus my concentration. You get a nice Excel graph. You can print out the equation of the line, and you know right away that the molar absorptivity for this particular substance is 3,114. It's going to be a big number, guys. If you get a small number, then you've done something wrong. We're plotting absorbance on the y-axis, concentration on the x. And the other thing is the concentrations are very, very small. Since the concentrations are very, very small, that's going to make this number very, very big. When I do my Excel graphs, I don't like to use scientific notation because my Excel doesn't react well to it. So I will put in 0.0001, 0.0002, and so forth, because I want to make sure that that number that's finally calculated is correct. Any questions from here, guys? So basically, our strategy for this lab, we are going to make a series of solutions with different concentrations. Then we're going to take all of these different concentrated solutions, we're going to put them into our instrument, and we're going to get the absorbances for all 4 of these. Then we're going to graph the absorbance versus the concentration, get the slope. The slope is going to be our molar absorptivity. Then, knowing that our absorbance is equal to molar absorptivity times the concentration, I'm going to take my unknown solution, put it into the instrument, and I'm going to get an absorbance. I'm then going to take the absorbance divided by my slope. That will give me my concentration. Are these hard problems? Natalie, you're going to be taxing your brain doing these this week?
No, hopefully not.
I hopefully not too, because if you are, then you don't deserve to be in Chem 2. These are not that hard, guys. So the first part of the experiment, you're going to be given a series of dilutions, and he's going to give you the absorbances. We just need the graph. That's all we need from that first set of answers. Next, we're going to get the concentration. I'm sorry, I need to move my ticket here. We're going to get the concentration of the dye. And we're going to have to dilute this, because if we put the dye in straight, it's just going to top out our instrument. So we have to dilute it. Then we're going to put the diluted solution into the instrument and get the absorbance. All right, couple of things that we need to be aware of again. We're going to be using M1V1 equal M2V2. Our first dilution has a concentration. The stock solution has a concentration of 4.75 times 10 to the minus fifth molar. I'm going to need to take 1 milliliter of that solution, put it into a 250 volumetric flask, and add the DI water to the line. Now, if you haven't ever used a volumetric flask before, it's the flask that has that big bubble on the bottom with the real thin neck on the top. The reason it is made like that is so that you get a whole big volume of the liquid, but it's got the neck so you can make the volume very, very specific. If we have a 250 milliliter volumetric flask, that number, when we put it right to the line, we have exactly added 250.0 milliliters. So we're going to do an M1 concentration of our stock solution times the amount we put into the volumetric times X divided by 250. Do that math out. We've got a concentration of 1.7 times 10 to the minus 7th. Do 5, do 10, and do, I think it's either 15 or 20. I'm not entirely certain at this point. Whatever the final volume is, do that. And you will get the 4 concentrations. Any questions about that one? Okay, you're then going to look at the data and you're going to see the absorbances you get. We're going to get the graph. We're going to get the slope of that graph. That slope is our molar absorptivity. In the course, guys, if you do not know how to graph in Excel, it is a technique that you're going to be very fond of once you get it, because once you have it, it's a lot easier to graph. You don't have to figure out the numbers. Remember figuring out the numbers in intro, guys, for the graphing lab? You don't have to do that again. Just do it on Excel. You're going to get the first column is going to be your X. Your second column is going to be your Y. First column is going to be the concentrations. Second column is going to be your absorbances. And again, the program I have for Excel does not like scientific notation, so you're going to have to put in the zeros. So if I have 2.33 e to the 7th, I got to put a decimal point, 6 zeros, then enter the 233. All graphs must have the X and Y axes identified. You got to label them. Not only do you label them with what you are graphing, but the units of what you are graphing. It needs a scale. If you do it by Excel, it's automatically going to be done for you. You're going to need a title. Title can be simply Y-axis versus X-axis. Somewhere in the graphing surface, you need to put the equation of the line. If you do it by hand, you must show the work for determining the slope. Remember, Y is the absorbance, X is the concentration. So basically, you are then going to take your Gatorade. You're going to dilute it, and you're going to put it into the instrument. We put it into the instrument, and we got a absorbance of 0.421. I did my graph. My graph turned out to be 83,500. I divided the absorbance by the graph. I ended up with my concentration of 5.04 times e to the minus 6. But you have to realize what you did. You put the concentrate, you put a known amount of your concentrated sample into the volumetric flask. So that is your known amount, your known volume. The amount of the volumetric flask is the amount of your diluted sample. You have your concentration of your diluted sample. You have the fact it was in 250 milliliters, and you know that the volume you originally put in of the concentrated sample was 30. All you simply got to do is another M1 V1 equal M2 V2, and you come out with the concentration of the Gatorade. If this number is not bigger than your diluted sample, then you've done something wrong. And I think that is it. Anybody have any questions about this? If nobody has any questions, then I am going to, go to the, nope, I don't want that. Let's do that. Yep, that was where I was supposed to go. Let's go first to the student data. Okay, gonna move this guy. Okay, here's the data. Don't worry, the path link you're never going to use. What in the world is going on here? Thank you. Path link you're not going to use. Stock solution, you will need that. You have, it is the 15th, so you have your 5 solutions. You have to determine what the concentration of each one of these 4 solutions are. All right. Now, I'm gonna look at this. I don't believe you're gonna need what he wants you to do in this laboratory, and it's stupid. He wants you to take the raw liquid, the raw Gatorade, put that into the instrument. You get a very high number. When the number is this high, you can't use it. So you got to figure out how much you're going to dilute that to. All right. You want to get it on scale. In this case, they decided they were going to dilute it about 1 to 8. They diluted it about 1 to 8. The absorbance went down. Again, because this number is not accurate, we can't use it. We have to dilute it. This is the diluted sample. This is how much of the diluted sample you added in. The 35 milliliters is the concentrated sample. Does anybody have any questions about the data you're using? I like cooperative people. All right, so I'm going to go back to table of contents, and we're going to go through the results section. I'm going to go back to the table of contents. There we go. Thank you. Okay, you're in here, gives you a video. It gives you a video. If you like watching them, go for it. If not, you don't really have to. Plot a graph in Excel. It gives you a program for doing that. You are going to need to imprint the graph There's a video tutorial on how to put a picture into the lab report. Then we get into the results. Preview. Start quiz. Everybody's seeing the screen, correct? Gaith, you seeing this?
Oh, yes, sir.
Okay. Simple questions. As always, he likes to throw some gimmies to you. The molarity of the stock solution, just show me. These are the solutions that you're making to make the graph. You just have to show me what the four molarities are and show me the calculation of how you got one of them. 35 points. Okay. Put in a picture. Put in the equation of your line of best fit. If it was determined by hand, if I see a hand graph, you got to show me how you got the slope and y-intercept. Put everything I ask you to put in for the graph. All right. Yeah, put in what the stock solution was before you diluted it. It's a useless number, but put it in anyway. Then you're going to put the absorbance of the solution after dilution. Now, the molarity of your diluted sample. You're going to do the A divided by molar absorption. You're going to take the absorbance of your diluted sample, divide that by your slope. That will give you your concentration. Molarity of the original sample, you're going to take the concentration you just solved for, multiply that by 250, and divide it by the volume of the concentrated solution you added to the 250 milliliters. And that's it, guys. Easy peasy. I told you guys that we only have one tough lab coming up, and that's going to be the Vesper lab. The next lab you do is going to be paper chromatography, simple. The one after that is heat of vaporization. Has anybody gotten to heat of vaporization yet? Intermolecular forces. Is Dr. Musgrave that far ahead of me? I'm getting crickets, guys. So nobody knows what I'm talking about. That's a good sign for me. All right. That lab is going to be done. And the last lab is going to be Vesper, valence shell, electron pair repulsion. And I may or may not flip those. For right now, just leave them where they're at. Questions about the results? Mr. Popovich, I just want to get out of here, so hurry it up. Right, Bethany? You want to go back to bed? I want to go back to bed. Who caused this god-awful time? Wasn't
Seriously.
What's that, Grace?
I said seriously, it's all your fault.
Yeah. You might as well blame me. My Chem 2 class is blaming me for failing. I mean, how can you blame me when you get 40 on an exam? That's not 40%. That's 40 out of 150.
Oh, well.
Yeah, that's what I said too. Okay, the post lab is going to be up here in a second. Okay, read through the lab, figure out why you used the lambda max. The lambda max is the point in the absorbance pattern in which the peak has absorbed the most light. It wants you to do, explain why. Okay. if the spectrophotometer read 10% low on every absorbance reading, how do you think that would affect the results? How do you think it's going to affect the results? If it's 10% low, is the molar absorptivity going to be is the slope going to be 10% low? Then aren't you dividing the unknown by a number that's 10% low also?
That sounds right.
Think about it. Okay. You got a formula there. Okay. Wants to know what the diluted solution is. Just question 3 is nothing more than redoing the experiment. Question 4 is a word problem. Okay, if you didn't know it, now you do. Products have an LD50 value. The LD50 value means that's when half the population dies. It means lethal dose. Okay? Now, they make an assumption that they, much as I would like to choose the population to do this test on, they won't let me take humans and test products on them for some reason or other. I would do a good job in choosing, you know that? So, because of that fact, we have to extrapolate our data from rats. And when 50% of the rat population dies, there's an assumption that 50% of the human population would die as well. So what you are doing here is you are doing a dimensional analysis problem here. All right. You're using 10,000 milligrams per kilogram in rats, and you're assuming that, let's see what else you're doing. Okay, what you're going to do is you've got the concentration, right? You have the concentration from your lab. All right. Now you've got the concentration. You've got to take 10 fluid ounces, turn that into liters, and multiply it by the concentration. That will give you moles. Okay. So you've got moles of the Allura dye, multiply that by the grams. That will give you the grams. All right. Assume the person weighs, unless it's in his problem and I'm not saying it, assume the person weighs 150 pounds. Everybody copy that down. The person weighs 150 pounds. So you are going to take your dye's concentration, multiply it by the 10 fluid ounces, change to liters. That will give you moles. Turn the moles into grams. Then once you have turned the moles into grams, you are going to divide that by 150 pounds changed into kilograms. And you're going to be able to compare it to the 10,000. Questions, guys? This one's a different problem. If it's going to assume that you had 8.2 milligrams of dye is 8.2 milligrams of the dye is required to reach the 10,000 milligrams. Assume the person has a body weight of 165 pounds. You have to calculate the number of glasses of the sports drink that you're going to need to consume to get to 10,000 milligrams. Any questions about these problems? The last two problems are just dimensional analysis problems. You guys are going to do fine on them. Don't you be yawning, Corey. Guys, that's all I have. You did not have a report, a results, or a post lab due today. You do on tomorrow night at midnight. Okay? And the notebooks. You did have, yeah, the notebook is due as well tomorrow. Any questions, ladies and gentlemen?
No questions, sir.
Anybody that has Dr. Musgrave, what topic are you on right now? Have you been through quantum mechanics? Quantum numbers? Bethany, who do you have?
I have Professor Stodden.
What subject are you doing now, Bethany?
The gas laws.
Okay. Now I know Jeremiah. Elaine, what are you on?
Same as Bethany.
You're in, okay.
Yes.
Gaith, who do you have?
Yeah, Professor Stodum, I think his last name is.
You
Yeah,
on gas laws as well?
Yes, sir.
Wow. I know where you are, Kyle. Monica, what are you doing?
Oh, same thing, same for purpose.
Okay, maybe I'm running it. Andrew?
Remember, I'm just taking the lab.
Okay. Okay. Last thing before we go. Mervina.
Here.
Thank you. Bethany's here. Gaith is here. Natalie's here. Kylie.
Here.
Okay. Everybody seems to be here today. Aaliyah.
Here.
I want to talk to you, Aaliyah. Corey's here. Abhishek.
Here.
Andrew.
Here.
Alexis.
Here.
Kyle, I saw. Marlene. Marlene. Christine.
Here.
Taylor.
Here.
Monica.
Here.
Adrienne. Adrienne. Elaine. Elaine, come on. I know you're here.
Here.
Jeremiah. Maria, I saw. Jonathan. Garrus.
Here.
Garrus, are you sure you're here? You didn't ask any questions. Check and see if you're really here, Garrus. T.
Here.
Larry, I saw, and Paige.
Here.
Okay, ladies and gentlemen, until Wednesday. Wednesday is going to be another really, really quick lab. It's a new thing like this is, but it really is quick. 3 more labs and we are on to the final, ladies and gentlemen. Yay.
Yeah, I heard we're getting extra credit just for the fun of it.
Hmm?
Yeah, I heard everyone gets A's actually.
Yeah,
Everybody except
what I
Gates.
heard.
Everybody
Lord.
except Gates. Anybody that brings it up extra points gets actually 5 points taken away.
Wow.
I heard you're giving negative points out.
With pleasure.
No, actually, real talk though, I do appreciate your lectures. However, I did hear you said you're gonna get rid of the final exam because you said it was not necessary. That's
Huh?
that's what I heard. That's what
Stop
I heard.
listening to that little bird, Gaith. It's going to lead you astray every time. Okay, guys, if it's not, I need to talk to Aaliyah for a second, and that'll be it then, okay? Unless anybody has any questions. Take care, guys.
What's the lab final gonna be like?
It's going to be like being chained to a wall with ants crawling up your leg.
Oh, well, I'm used to that. That'll be okay.
Good.
You know, as
No,
funny
honestly,
as this sounds,
if you want to study for the lab final, the best way you can do it is to just redo the labs. Because
Oh boy. Cool.
everything is kind of meshed in there. That's the best way I can tell you to study for the final.
oh wow, yeah, I'd rather have ants crawling on me.
Yeah, same here.
I'll see if I can arrange it. Take care, guys. I need to speak to Aaliyah for a second.
All right, Professor, thank you. Oh, I'm sorry, I forgot to ask you. The graph you mentioned Excel. We don't have to use Excel. You said, right?
No, you do not have to use Excel.
Oh, I got it. Okay. Thank you.
Page.
So I have you for lecture as well, and I was curious when test 2 is going to be.
It's on Wednesday.
Wednesday?
Yes.
Okay. Are we also allowed to have like one sheet of paper, front and back of notes again?
Everybody except you, since you asked.
That's not fair. All right, thank you.
Yes, Paige, you're allowed to have an 8.5 by 11 sheet of paper, handwritten.
All right, thank you.
You're welcome. Okay, guys, Garrus, you have a question?
Yeah, I had a question. So for when we write down the equation of a best fit, do you want us to just write the X
Yep.
number, which is the molar absorptivity, or did you want us to write like the extra number, which will be like plus or minus?
I am sorry, I'm not understanding what you're saying you're trying to
So-
add a standard deviation in there.
No, in the
Oh,
equation.
the R
it's-
squared thing? Are you thinking about the R squared thing?
No, in the equation, it's y equals mx plus b.
Yes.
Did you want us to put the plus b in the equation when we write it down, or just the mx?
Just the MX. Or
Okay,
Garrus, are you doing it on Excel?
yes.
If you're doing it on Excel, then print out the graph. You're not gonna calculate the slope by yourself. You can print out the equation right on the graph. Just do that. That's all I want.
Yeah, and when it gives the equation, it gives the additional number.
That's fine. Don't worry about it.
Okay,
All I'm
And then-
interested in is the slope.
okay. I was also confused a little about what the difference between finding the molarity of the diluted solution was and the original solution.
Okay, what the original solution is too concentrated, Garrus. Okay, you put it in there, any number of absorbances that is higher than 1 is inaccurate. Okay, Garrus?
Mhm.
So when you put the concentrated in there, you got a number like 2.63. The only reason you put that in there was to get an idea of how much you had to dilute the sample down. You wanted to get a number somewhere in the range of around 0.5, so you decided to dilute it by 8. This is the logic behind the experiment. I don't do that. I just tell them how much to put in. Okay, I just tell you guys, when you're doing this face-to-face, I will tell you to put 30 milliliters of the concentrated in. So you
Okay,
don't have to do that.
so
Oh, okay, so you've made your concentrated sample dilute so it can be read in the instrument, right?
mhm.
So you read the absorbance, get the molar absorptivity from that dilute sample, and you have the concentration of the diluted sample, right?
Mm-hmm.
That's not the question you want. You want to know what the concentration of the concentrated sample is. So if you know how much volume you put of the concentrated into the 250 milliliters, you know what the concentration of your dilute is. You know what the volume of your dilute is. You also know the volume of your concentrated. Use those three numbers to solve for the fourth.
Okay, so just to like run through the calculation, you would take the absorbance and divide it by the slope that you get to get concentration. And then from there, you multiply the concentration by the total volume.
Yes, because
And
that's
then
that total volume, that 250 is the volume of your diluted sample. And you got the absorbance of your diluted sample, right?
Mhm.
So you've got the concentration of your diluted, you've got the volume of your diluted. That's equal to the concentration of the concentrated sample times the volume of the concentrated sample, right, Garris?
Mhm.
So you're going to take the 250 milliliters, multiply that by the concentration of your diluted sample, make that equal to X molarity times, in this case, they're telling you to use 35.
Okay. All right.
Okay?
Yep, that makes sense.
Okay, Carol, so I'm going to have to ask you to get off now, all right?
All right, thank you. Have a good day.
You're welcome. I'm sorry, Aaliyah, I now have to, okay, 1 second.